Students, this is our tutorial. I am continuing discussing about analytic geometry 2D, two-dimensional. So already straight lines, circles, parabola, ellipse are completed. Now today I discuss about hyperbola. So how hyperbola's equation can be obtained, and the way I will discuss. So let's start. I have already discussed that if eccentricity is less than 1, then we will get the geometrical figure is called ellipse, and is eccentricity equal to 1, then we will obtain the geometrical representation. This is parabola, and if eccentricity is greater than 1, then we will get hyperbola. So this is the required condition. Now in Cartesian plan, a hyperbola can be drawn in this way. There are two axes. This is x-axis and this is y-axis. Now we will take a directrix first. This is the directrix. This is a straight line, fixed straight line, and a hyperbola in this way. This is the origin O, and this is the vertex. Vertices. This is called vertex. Vertex we will take A0 at first. A0 at first. Now the fixed point will take the focus of the hyperbola. So this is step n, and any variable point we will take here. This is s is xy. Any variable point, this arises with the taking different values of x and y with the condition of eccentricity greater than 1. So there is a perpendicular. This is sp. Sp is less than Sm, means Sm greater than Sp. This is the condition of eccentricity, that Sm must be greater than Sp. Then we will get the eccentricity greater than 1. Sm must be greater than Sp. Now, if we take a mirror put a mirror on the y-axis, then get a image of the directrix first, the same distance from the mirror for y-axis. This is the another directrix, the image of this directrix, and a hyperbola same as the hyperbola on the right hand side. This is also the image. So I am taking here. This will be the vertices. This is vertices. This will this because it is a mirror. I am putting the y-axis. So the image will form the same distance minus a 0 minus a0 minus a0. Minus a 0. So this is the vertices of the image of this hyperbola, and there will be the focus. I am putting this as m prime. This is also the same distance as from the OA, is the distance OM will be, the OM prime will be the same distance. So there is the OM M prime. Now I am adding in this way to make understand very easily. Now to calculate the equation of the hyperbola, we will have to find out that we just know about the vertices coordinate A0, nothing more, and the eccentricity condition. So we have to use this condition. We have to deduce OM first. OM the OM will give you the coordinate of the focus. So we have to calculate OM and ON. ON will give the equation of the directrix. These two are very important to formulate. So here we know SM greater than SP, or SM by SP is equal to SM by SP is equal to E. So E will be SM by SP, which is greater than 1. Now simply I am deducing when the variable point will come here at the vertices, then we will get here we are getting putting A, we will get AM by AM by AM, which is also the equal to the eccentricity AM by AM, and we will get AM by AM. This is A is equal to, when the variable point, I imagine that when the variable point comes at this point, just imagine that if you put this image in the right hand side, on the imagine side, and when the point imaginarily comes at this point, then what is the condition says? Condition says that here I have not taken any point, I am taking this A prime, this is A prime point. So here uh, a a prime to m distance, a prime m, a prime m by a prime m by a prime n. This is a distance from the directrix. This will be also the equal to the eccentricity. Now one thing you have to note that am, what will be am? Am is equal to am, we have to find out. Am we have to find out. So am is we can obtain by OM minus OA, and an we can calculate when OA minus an OA minus ON. So ON and OM is required, we used to find out. That's why we will represent this fully to OM and ON, and this is also represented by the known values, the required values, OM, OM prime, and uh, ON prime, ON prime here, N prime. So then what will be it will be changed. I'm writing here. This will be changed. E equal to, from this we will get OM, AM will be OM minus OA. So OM minus OM minus OA equal to A. We have already taken. And in this, and last in the denominator, an will be OA minus OA. OA is A, So A minus ON. A minus ON. Now from the last what we will get? I'm erasing this. From the last we will get AM prime M. AM prime M. AM A prime M, sorry, A prime M, this distance, so it will be expresses as uh, OA prime, which is A, distance A, because this is the distance, this is A and OM. So we will take A plus OM. A plus, you can very easily look this, A plus OM. This is OM is uh, OA prime is A and OM. Below, what is the A prime N? A prime N, A prime N will be uh, OA prime this distance plus ON. So we'll take OA prime is A plus ON. Now if we use error dividend, just the law that on this equation, that numerator plus numerator and denominator plus denominator, then we will get very easily, and cancelling 2 then we will get OM by A, OM by A. And if we subtract numerator minus numerator, denominator minus denominator, it is valid in equation, and it can be proved. It is a secondary level of proof. You already known about this, that you can add numerator and denominator, and also you can subtract numerator and denominator. We will get same result, equal to false. So we'll get here cancelling -2, then we will get A on the numerator and below ON. So from this relation, both are equal to E. Both are coming from E, eccentricity. So here we will get OM equal to AE, and ON we will get A by E. So now we have find out another page. Now OM equal to, we have obtained E, and this gives the coordinate of the focus. ON, which will give the equation of the directrix, you will get A by E. Now if we take the condition that SM by SM by SM by um, SP equal to E, then what will be SM? SM will be the distance from the fixed point M and the variable point S, which will be V square. Then this will be the whole square, this will be the whole square, and this will be the whole square. So SM whole square will be the distance from the one fixed point and one variable point. This will be the x minus E whole square plus y whole square, and on the right hand side we will get e square, and sp will be the distance from the variable point to the directrix equation. Directrix equation we will get x equal to a by e. This is the directrix equation. So if we put here, we will get x minus whole square form. That's why x minus a by e whole square, and below root over 1. So root over 1 1, and 1 whole square is 1. So writing 1. Now if we extend further, this will be x square minus 2 x e plus e square, e square, and e square plus y square. And on the right hand side we will get just using a minus b whole square and multiply e with e square, we will get e square x square minus x square, 2ab, and multiplying with a square we will get 2x e plus b whole square, multiplying with e square we will get just a square. So on the right hand side and the left hand side we will cancel this. Both terms have the same sign and both are equal. So now we will getting just will uh, uh, carry this term to the left hand side, and this term from the left hand side to the right hand side, and get x square since this is e square is greater than. So we'll first uh, we'll taking that not this e square is greater than 1. So we'll take in another way, a square e square minus a square. A square is carried to the left hand side, then a square equal to e square minus 1, and on the right hand side we will get x square e square minus 1 plus y square. Then I have to just divide all the terms by a square multiply a square minus 1. Then we will get a equation such in this form, x square, and cancelling the equal to x square by a square plus y square e square. Here I am writing e square minus 1, e square minus 1 divided to 1. You can keep this in this form or can change this in this way, square by e square minus, taking minus from this, get y square by e square and 1 minus e square is equal to 1. Now, in the chapter of ellipse, when I have lost the video ellipse, I have said this will be equal to b square. I have already said that b square is related to this uh, a square with this relation a square minus 1 minus a square. So you can replace this b square by a square 1 minus a square. You will get the equation in the terms of a square minus a in the terms of a and b, where a and b are the vertices. So I there is some differences. I must want to share that in ellipse and hyperbola there is some differences. In ellipse there was major axis and minor axis. Major axis coordinate in the a0 and minus a0, and minor axis coordinate in points coordinate 0b and 0 minus b. In case of hyperbola, the called actually transverse axis is in points vertices we have taken minus a0 and minus a0, and if we will take the minor axis, this axis, this is called the conjugate axis. This is called the transverse axis. This is called the conjugate axis, which will be 0 b and 0 minus b. In points coordinate will be 0 minus b in such a way that the distance must be equal from the x-axis. If this point, this is u, you will take am, then OM and OM prime must be equal. Then this axis is called conjugate axis, and this axis from this vertex to this vertex is called transverse axis, and its point coordinate a0 and minus a0. Thanks. I think you have understood this, and enjoy all the videos, and of course subscribe this channel to get the latest videos on basic mathematics. Subscribe, you first get the videos. So must subscribe, share with your friends, tell them to subscribe this channel and enjoy all the videos I am lodging. And if you have any comment me in YouTube. You have a comment box also in my channel, so must comment me, must comment which you like, which you dislike. You have any request to add any video in this channel, so must comment me. I must add that in this channel.